Alright, so my first example for inverse circular function derivatives is sine to the minus 1 of 4 minus x. As I mentioned in the notes, when we want to differentiate these, we have to use the chain rule. You will probably never get a problem where you just go straight to the formula that's on the formula sheet. So this is a little bit tricky. The first thing to help me work through this is I'm going to start by writing it as y equals sine to the minus 1 of 4 minus x. That's just going to help me a little bit with the notation. So it's not a straightforward derivative problem because I've got this function inside the brackets. So I need to work with that separately. And the way I'm going to manage that for some of these more complex questions, as I mentioned, is using the chain rule. So I'll start by letting u equal 4 minus x, and so du dx is equal to minus 1. And then over here I can rewrite this expression as y equals sine to the minus 1 of u, and the derivative of y with respect to u is 1 over the square root of 1 minus u squared. To find out dy dx, I use the chain rule and put those two parts together. So it's dy du times du dx, because essentially these two parts will cancel each other out. And when I put those two bits together, I get 1 over the square root of 1 minus u squared times by negative 1. By substituting in the u value back into the expression and managing that minus 1 on the end, I end up with minus 1 over the square root of 1 minus 4 minus x. That was a terrible x. Let's try that again. 4 minus x squared. Okay, and there's my derivative. But in this case, I do have to give it a little bit more thought. This bottom line must give a positive value under the square root sign. So if I want, I can find out by solving that quadratic that's in the square root, solve it being greater than, so I can do 1 minus 4 minus x squared has to be greater than 0. Or I can go to my original function and think about, well, what was my graph? I know that sine theta, try that again. I know that inverse sine theta has a domain of minus 1 to 1. Now if I want, I can write that as theta must be greater than or equal to minus 1 and less than or equal to 1. And in our case, our theta is 4 minus x, so it must be less than 1, greater than or equal to minus 1. Now if I times everything here by negative 1, I flip my signs around and I get x minus 4 is greater than minus 1 and smaller than 1, and then add 4 to everything, then I'll end up with a 5 here, x in the middle, and 3 on this side. So my derivative will exist where x, try that again, where x is greater than or equal to 3 and less than or equal to 5. So this will give me zeros in the bottom, but the extra little part here is derivatives don't exist at the endpoints. So if I go a little bit further on this problem, the endpoints existed in the original function inverse sine of theta, but the endpoints won't exist in the derivatives, so I don't want equal to. So I can write my final expression for the derivative as dy dx equals -1 over the square root of 1 minus 4 minus x squared, where x is greater than 3 and less than 5. And that's the answer.